Hello there, my name is Johnson Makmot, Kabira, software engineering, and I'm going to be presenting part B of large vision models for multi-disease retinal screening in Uganda healthcare, and belong to group 52 of AI. So, getting moving on. Um, our deployed AI software system is already pushed and it's already deployed, and the link will be submitted in the form, and it's already there, and demonstrating how the whole AI retina system works and how it operates live. So moving on, the problem and spectral parts for this project is we have an objective whereby high prevalence of diseases like diabetic retinopathy, glaucoma, hypertensive retinopathy, and more other eye diseases. Well, what is our problem? Our problem is we want to solve limited access to ophthalmology, since very many people cannot access these ophthalmologists easily. We want to have a system whereby this thing is embedded and can provide access anywhere, especially in rural areas. So, who experiences it most? Patients in rural areas. And why is this AI essential? Because it provides content-based reasoning and decision of a certain eye disease and lowers on certain retinal scan diagnosis time. Yeah, and the measurable impact is to reduce the time spent, because when you deal with one ophthalmologist, there's a lot of time to work on so many patients, but this will help reduce that time. So our users, stakeholders, and ecosystem actors, we have the primary users who are the ophthalmologists and people with eye disease. Then, of course, the secondary ones are the hospitals, Ministry of Health, the NGOs like World Health Organization, and also society or groups which are indirectly affected. The ecosystem roles, we have the data suppliers, the API consumers, algorithm designers, and platform maintainers. And the governance entities will involve the oversight by NITA Uganda, then Ministry of Gender and Labour, Ministry of ICT. Then our data sources and value, we have the Retina Fundus multi-disease image dataset, where we got our dataset from, and that is our platform, which consists of original color fundus images, which are 3,200, and the disease having more than 10 images belong to an independent class, and all the other diseases constitute 28 diseases. So those are the classes, which are 28, and the source where we got the image, the sources are always the images, and the data types are the open dataset from Retina multi-disease image dataset. And the process pipeline is collection, cleaning, annotation, validation, and storage. And the ethical and legal framework is simple compliance with National Data Protection Acts, informed consent, and the value mechanism is the images used during training provide the backbone for the knowledge base. So moving on to the solution and AI system description. So here we describe our AI-driven solution, its architecture, the core logic, and the technical distinctives. So what AI methods or algorithms are used? We have the graph clip, we have the visual language GNN, we have the scene graph transformer, and the VIGNN. So these models involve inputs and outputs, but what are they? We have the retinal image scans, those are like the images, which are the inputs. Then we output the prediction of the disease in the percentage. How does this AI generate these decisions, and how does it integrate users, workflows, existing systems, or the APIs? We're looking at all these problems, and also what responsible AI mechanisms are embedded. Yeah, those are our solutions. The key metrics and evaluation. Well, we define how success is measured technically, ethically, and commercially. So the technical metrics involve the accuracy, the F1 score, latency, throughput, uptime, and error rate. So user-centric metrics, there's adoption rate, session duration, user satisfaction, and net promoter scores, which are the NPS. The ethic metrics involve fairness, interoperability, and bias mitigation, and transparency score. Then the business metrics, of course, shall look at acquisition, customer acquisition cost, the lifetime value, and the churn rate, revenue growth, and return on AI investment. Okay, so unfair advantage and differentiation is here we identify your unique competitive edge and how it creates defensibility. What do you have that others can what? Can easily copy. That's what we are looking at. And for example, these proprietary data sets, IPs, the partnerships, and we also look at what learning or feedback loops strengthen our product over time. And what does our AI model infrastructure sustain the long-term differentiation? Those are objectives we look at. So the channel distribution, this one involves the medical personnel who has a computer where he can upload all the retinal scan images. Then you can also attach an external eye specific camera that accurately captures this retinal scan and uploads them directly to the system to get results. So acquisition channels, we have partnered with the MIC Lab to be able to get some of those acquisition channels to see how we can get assistance, and Unipod as well. Then delivery channels, we have a free web interface that can be accessed by doctors with a free API endpoint. Then the partnerships, we have a collaboration still with MIC Lab, and also the retention tactics is continuous updates and more model training for increasing the retinal scans from around the world. The revenue streams, here is where we look at the money and the income generation. So here we have the direct revenue models where there is subscriptions, like SaaS. Then we also have that is licensing fees, then pay-per-use APIs. And then the indirect revenue shall also get the DaaS, which is data as a service, the consulting services, and the ecosystem partners. Then the added value added streams, which shall get direct one-time sale of maybe basically to governments in development countries. Yeah. So the key resources, here we are looking at critical enablers of AI development, deployment, and sustainability. And we're looking at the human resources, whereby we have the AI engineers, the ML researchers, the data scientists, and the medical personnel. Then we also have the technical infrastructure, whereby we have Hugging Face, TPUs and GPUs, the pipelines, and also ML Ops tools and CI/CD pipelines with GitHub workflows. Then the data infrastructure involves the data retinal fundus, multi-disease image data set, and organizational resources are institutional collaborations, whereby we have the market incubation in innovation lab. Then the financial resources, we have seed funding grants, venture capital, and strategic partnerships. Key activities still moving on. We still have model life cycle activities where there's data acquisition, labeling, modeling, model training, testing, retraining, and deployment. Then the product development activities feature engineering, UI UX design, APIs, testing and integration. Operation activities will be monitoring model drift, maintaining the data pipelines, ensuring uptime and security. Governance and compliance, conducting AI audits, bias assessments, and aligning with regulatory frameworks. Customer focused activities, these are technical support, community building, and user feedback loops. The technical partners still involve, these are the key partners, and we have the technology, data, and ethical oversight partners, distribution partners. So the technological partners, these are like cloud service providers like Hugging Face, Azure, GCP, API platforms, and AI research labs. Then we also have the data partners like universities to provide us with this data, NGOs, the government bodies, and open data repos on GitHub. Then we can also have the ethical oversight partners, which are like regulatory agencies, ethic boards, and accessibility councils. The distribution partners are telecoms, digital hubs, fintechs, and e-learning systems. Strategic collaborators, which involve the investors, the accelerators, virtual studios, media outlets. So cost infrastructure, our costs, we are looking over 200M annually for labeled datasets and local collection from various regions. In the compute and infrastructure codes, we look at the GPUs, TPUs, cloud storage, bandwidth, and APIs. Then the HR costs, salaries for AI engineers, of course, and data scientists and product managers and ethicists. The compliance and legal costs, we look at the data protection, auditing, certification, and intellectual property protection. Marketing and distribution, we shall look at the community outreach, customer acquisition, events, promotional materials. Then moving on, maintenance and scaling costs. We shall do continuous training to maintain the model and also model optimization and scale the cloud scaling. So looking at the governance, ethics and compliance, here we want to institutionalize responsible AI practices to ensure trust, fairness and accountability. So we have the governance model, whereby here we look at MakeHub and we can collaborate with Dr. Gariwango to meet the intended expectations. Then fairness and bias auditing, we can look at regional model benchmarking and comparisons with other models so that we can find a way of improving. Then transparency mechanisms, we have an open model on Hugging Face that one can interact with the interacted through using the APIs. Then explainability tools, we have Sharp, Breadcrumb, Counterfactuals, and Line. Those are most of the tools we can use to explain our concepts. Then the legal and ethical frameworks, we have GDPR, PDA, Uganda, UNESCO, which will recommendation on AI ethics. Then accountability, here all the queries will be made to the model or endpoints that are stored for reference if needed. The scalability and sustainability, we have the continuous learning, localization, financial sustainability, environmental responsibility, and resilience. Yeah. So here, the microservices in scalability framework, then in continuous learning, here there is continuous model updates, original images, then also support on English for localization. Then we also get revenue investment, partnerships, and grants for financial stability. And we ensure energy efficient model architectures uh, to ensure environmental responsibility and backup systems to ensure resilience, right? So intellectual property and innovation identify potential intellectual assets like algorithms. And here, our idea, we are finding out whether our idea is patentable, copyrightable, or protectable. Yeah, so this will also involve our intellectual property to ensure that we copyright this product. So contributions, well, I did model visualization and dataset acquisition, and the rest did also their parts. And yes, that is all I had for you. Thank you very much, and have a good day.